The advice provided by a big box store regarding electrical installations is highly questionable. It lacks technical soundness and fails to adhere to established building practices. Using a piece of flat metal bent into the shape of a single gang box as a mud ring is an unorthodox and potentially unsafe solution. Mud rings are specifically designed to provide a secure and stable base for electrical boxes, ensuring that they are properly supported and protected within the wall cavity. They help to prevent the box from moving or becoming dislodged, which can lead to electrical hazards. Using an improvised solution like the one suggested by the big box store could compromise the integrity of the electrical installation, increasing the risk of electrical faults or accidents. The advice given by the big box store not only disregards proper electrical practices but also highlights the need for qualified professionals in the field. Electrical contractors possess the necessary knowledge, skills, and experience to ensure that electrical installations are carried out safely and in accordance with building codes. They can provide guidance and support to homeowners, helping them make informed decisions about their electrical projects and avoiding potential hazards. While big box stores may offer a wide range of products, it is crucial for customers to exercise caution and seek professional advice when it comes to electrical matters. Attempting to perform electrical work without proper knowledge can lead to serious consequences, including electrical fires, shock hazards, and damage to property. Homeowners should always consult with qualified electricians for electrical installations and repairs to ensure safety and compliance with electrical codes. Understanding the purpose and proper application of electrical components is essential for ensuring the safety and reliability of electrical systems. Here's a more detailed explanation of electrical boxes, mud rings, and related concepts. Firstly, electrical boxes serve as enclosures for electrical connections, protecting them from physical damage and preventing accidental contact with live wires. They are typically made of metal or plastic and come in various shapes and sizes to accommodate different wiring configurations and device types. Secondly, mud rings, also known as plaster rings or extension rings, are used to extend the depth of an electrical box, allowing it to be flush with the finished wall surface. They are particularly useful when installing electrical boxes in walls with thick plaster or drywall. Mud rings are typically made of metal and are attached to the front of the electrical box using screws or other fasteners. Thirdly, the National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, covering everything from wiring methods to grounding and bonding requirements. It is essential for electricians and homeowners to follow the NEC to ensure the safety and compliance of electrical systems. Fourthly, qualified electricians are trained professionals who have the knowledge and skills to install and repair electrical systems safely and effectively. They are familiar with the NEC and other relevant codes and standards, and they have the experience to identify and address potential electrical hazards. Fifthly, electrical safety is of paramount importance when working with electricity. Electrical shocks can cause serious injury or death, and electrical fires can cause extensive property damage. It is essential to take precautions such as turning off power before working on electrical circuits, using insulated tools, and wearing appropriate personal protective equipment. When selecting electrical boxes and mud rings, it is important to consider the following factors. 1. The size and shape of the electrical box should be appropriate for the intended application. 2. The mud ring should be compatible with the electrical box and should provide adequate support and protection. 3. The materials used in the construction of the electrical box and mud ring should be durable and resistant to corrosion. 4. The electrical box and mud ring should be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all, to ensure that they meet safety standards. When installing electrical boxes and mud rings, it is important to follow these steps. 1. Turn off power to the circuit before starting any work. 2. Carefully remove the existing electrical box, if applicable. 3. Install the new electrical box in the wall cavity, ensuring that it is securely fastened. 4. Attach the mud ring to the front of the electrical box using screws or other fasteners. 5. Make the necessary electrical connections following the NEC and other relevant codes and standards. 6. Test the electrical circuit to ensure that it is working properly. In addition to the above information, it is also important to be aware of the following common electrical hazards. 1. Electrical shock can occur when a person comes into contact with a live electrical wire or component. 2. Electrical fires can occur when electrical wires or components overheat, causing insulation to melt and ignite nearby materials. 3. Arc faults can occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. 4. Ground faults can occur when electricity flows through an unintended path to ground, such as through a person's body. To prevent electrical hazards, it is important to 1. Turn off power before working on electrical circuits. 2. Use insulated tools. 3. Wear appropriate personal protective equipment. 4. Inspect electrical cords and components regularly for damage. 5. Avoid overloading electrical circuits. 6. Install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms and kitchens. 7. Have electrical work performed by qualified electricians. Electrical systems are governed by a complex interplay of regulations, standards, and best practices, all designed to ensure safety and prevent hazards. Understanding these elements is crucial for anyone involved in electrical work, from homeowners undertaking minor repairs to licensed electricians installing complex systems. Let's delve into some of the key aspects. Firstly, the National Electrical Code, as previously mentioned, is the cornerstone of electrical safety in the United States. It's a comprehensive set of guidelines developed by the National Fire Protection Association, or NFPA, and updated every 3 years to reflect the latest technological advancements and safety concerns. The NEC covers virtually every aspect of electrical installations, from wiring methods and overcurrent protection to grounding and bonding. Secondly, local building codes often incorporate the NEC, but they may also include additional requirements specific to the region or municipality. These local codes can address issues such as seismic activity, extreme weather conditions, or unique architectural styles. It's essential to be familiar with both the NEC and any applicable local codes before undertaking any electrical work. Thirdly, Underwriters Laboratories, or ALL, is a globally recognized safety certification organization that tests and evaluates electrical products to ensure they meet established safety standards. UL listing indicates that a product has been rigorously tested and meets the minimum safety requirements for its intended use. Look for the UL mark on electrical boxes, wiring, and other components to ensure they have been properly certified. Fourthly, grounding and bonding are critical for preventing electrical shock hazards. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Bonding connects all metal parts of an electrical system together, creating a low impedance path that minimizes voltage differences and reduces the risk of shock. Fifthly, overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. These devices automatically interrupt the flow of electricity when the current exceeds a safe level, preventing damage to wiring and equipment and reducing the risk of fire. Sixthly, arc fault circuit interrupters, or FSIs, are advanced circuit breakers that detect arc faults, which are dangerous electrical conditions that can lead to fires. FSIs are required in many areas of the home, particularly in bedrooms, to provide enhanced protection against electrical fires. Seventhly, ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can occur when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are required in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Eighthly, wiring methods refer to the types of cables and conductors used in electrical installations. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, and electrical metallic tubing, or IMT. Each wiring method has its own set of requirements for installation and support. Ninthly, electrical boxes provide a safe enclosure for electrical connections and devices. They are available in various shapes and sizes to accommodate different wiring configurations and device types. The electrical boxes must be properly sized and installed to ensure adequate space for wiring and to provide mechanical protection for the connections. Tenthly, electrical permits are required for many types of electrical work, particularly new installations and major alterations. Permits ensure that the work is inspected by a qualified electrical inspector to verify compliance with the NEC and local codes. Obtaining a permit is essential for ensuring the safety and legality of electrical work. When working with electrical systems, it's crucial to follow these best practices. 1. Always turn off the power at the circuit breaker before working on any electrical circuit. 2. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. 3. Never work on electrical systems when you are wet or standing in water. 4. Carefully inspect all wiring and components for damage before use. 5. Follow the manufacturer's instructions for installation and operation of all electrical equipment. 6. If you are unsure about any aspect of electrical work, consult with a qualified electrician. 7. Never attempt to bypass or disable safety devices, such as circuit breakers and GFCIs. 8. Keep electrical panels and equipment clear of obstructions. 9. Regularly inspect electrical systems for signs of wear and tear. 10. Have electrical systems inspected by a qualified electrician on a regular basis. Electrical installations are governed by the National Electrical Code, or NEC, which provides comprehensive guidelines for safe and compliant wiring practices. The NEC outlines specific requirements for box fill, which refers to the maximum number of conductors, devices, and fittings that can be installed in an electrical box. Understanding box fill calculations is crucial for ensuring that electrical boxes are not overcrowded, which can lead to overheating, insulation damage, and potential fire hazards. Here's a breakdown of the key factors involved in box fill calculations. Firstly, conductor fill refers to the space occupied by the conductors inside the box. The NEC specifies the allowable conductor fill based on the wire size and the volume of the box. Table 314.16. And the NEC provides the volume allowance for different conductor sizes. Secondly, device fill refers to the space occupied by devices such as switches, receptacles, and dimmers. Each device counts as a certain number of conductors based on its size. The NEC specifies the device fill allowance in Article 314.16. B. Thirdly, equipment grounding conductor fill refers to the space occupied by equipment grounding conductors. The NEC allows for a single deduction for all equipment grounding conductors entering the box regardless of the number of conductors. The deduction is based on the largest equipment grounding conductor entering the box. Fourthly, conductor fill deductions are made for certain fittings and devices that take up space inside the box. These deductions are specified in Article 314.16. B of the NEC. Examples of fittings that require deductions include cable clamps, internal cable connectors, and fixture studs. Fifthly, box volume is the total volume of the electrical box, measured in cubic inches. The box volume is typically marked on the box itself. To calculate the allowable box fill, you must first determine the box volume and then subtract the appropriate deductions for devices, equipment grounding conductors, and fittings. The remaining volume is then used to determine the maximum number of conductors that can be installed in the box. Here's a step-by-step guide to calculating box fill. 1. Determine the box volume. This information is typically marked on the box itself. 2. Determine the number and size of the conductors entering the box. 3. Determine the device fill allowance for each device installed in the box. 4. Determine the equipment grounding conductor fill allowance. 5. Determine the conductor fill deductions for any fittings or devices that take up space inside the box. 6. Calculate the allowable box fill by subtracting the deductions from the box volume. 7. Compare the calculated allowable box fill to the actual conductor fill. The actual conductor fill must not exceed the allowable box fill. Let's illustrate the process with an example scenario. Suppose you have a 4-inch x 4-inch x 2.125-inch metal electrical box with a volume of 30.3 cubic inches. The box contains 6 number 12 American wire gauge or AUG conductors, 1 switch, and 2 equipment grounding conductors. To calculate the box fill, follow these steps. 1. The box volume is 30.3 cubic inches. 2. The conductor fill for 6 number 12 AWG conductors is 6 times 2.25 cubic inches per conductor, which equals 13.5 cubic inches. 3. The device fill for 1 switch is 2 times 2.25 cubic inches, which equals 4.5 cubic inches. 4. The equipment grounding conductor fill is 2.25 cubic inches, since the largest equipment grounding conductor is number 12 AWG. 5. There are no conductor fill deductions in this example. 6. The allowable box fill is 30.3 cubic inches minus 13.5 cubic inches minus 4.5 cubic inches minus 2.25 cubic inches, which equals 10.5 cubic inches. Since the actual conductor fill of 13.5 cubic inches exceeds the allowable box fill of 10.5 cubic inches, the box is considered to be overfilled. In this case, you would need to either reduce the number of conductors or devices in the box or install a larger box. The NEC also provides guidelines for the installation of electrical boxes in various types of construction. For example, when installing electrical boxes in walls, the NEC requires that the boxes be securely fastened to the wall studs or other structural members. The NEC also specifies the minimum distance between electrical boxes and combustible materials. In addition to box fill calculations and installation requirements, the NEC also covers other aspects of electrical box selection and usage. For example, the NEC requires that electrical boxes be suitable for the environment in which they are installed. The electrical boxes installed in wet or damp locations must be listed for wet locations. Electrical boxes installed in hazardous locations must be listed for hazardous locations. Electrical boxes must also be listed for the type of wiring method used. Electrical boxes used with non-metallic sheath cable or NM cable must be listed for use with NM cable. Electrical boxes used with electrical metallic tubing or EMT must be listed for use with EMT. In conclusion, understanding box fill calculations and NEC requirements for electrical boxes is crucial for ensuring the safety and compliance of electrical installations. By following the NEC guidelines, you can avoid overcrowding electrical boxes and prevent potential electrical hazards. Always consult with a qualified electrician if you have any questions about electrical box selection, installation, or usage.